Hello, dear learner. Am I audible? Am I audible to you? Please respond in the chat box. Am I audible? Hello, Ganpati sir has joined already, and the session is live now. If you all are ready, we shall start the session. Okay, so I welcome Dr. Ganpati Mandali, sir, and then sir is going to handle our the MAEC 103, that is the statistical methods, which is vital actually. And this along with quantitative methods are two papers which are actually mark scoring, and mostly it is simplified version of what it was there last year, and this is easier than what it was there last year, but it covers all the relevant areas which needs to be applied in other courses, including your econometrics next year. Okay, so please have patience and then try to understand and then practice this. The purpose behind keeping it towards the end is that you should learn this closer to the examination so that you can retain what is there, and then your exam will be sometime in February. So try to complete it at the earliest. I would also request that to finish the course, and then the other two courses at least we have progressed a lot. So we'll try to finish the syllabus in time. So I welcome you, sir.
Thank you so much, sir, for your kind
Now,
greeting.
in between, learners can ask using the chat box. Okay.
Sure, sir.
So maybe
Okay, thank you,
after
sir.
every unit, you can give some chance to them so that they can clear their doubts. Okay. Thank you, sir.
Okay, thank you so much, sir, Dr. Das, sir. So, dear learners, today that I'll take your statistic paper and block one. Here we have that basically uh, four unit. First one is that measures of central tendency, that our all averages. And second unit is also that measures of central tendency, but it is positional average. Third unit is the measure of dispersion, and the fourth unit is the again that measures of dispersion, what it is the squareness and kurtosis. So why before going to the main theme, that what is average? So here in day-to-day life, this average or that arithmetic mean is of utmost use. Okay, so now why this average is have a very uh, large that consultation. Why the people that always talk averages? So here the average is nothing but an attempt to find one single figure to describe the whole figure. Now, suppose if I give you one example, that let's say in your class, that what is the average height of the students? Maybe the height of the students may differ. That that someone may be 6 feet, that someone may be 5 feet 4 inch, someone may be 5.6 inch. But that means now suppose if we compare the average height of two classes. Now suppose in first year class the average height is 5.6 inch, and in the second year class the average height of the student is, let's say, 5.8 inch. That means that we can conclude by a single figure that average height, that the second year students are taller than first year students. Here we are not taking into consideration the heights of all the students one by one, but a single value, okay, that 5.6 inch or that 5.8 inch, that will indicate uh, uh, the features of the whole class. Like taking another examples, average mark. Now suppose in mathematics, the average mark of the students is let's say 98. or 95. Okay, and in English, the average marks of the student is, let's say, 85. That means from this one figure that you can conclude that the students are doing better in mathematics than English. Okay, so that English they are poor, and in mathematics they are fair or they are doing well. So this average. Okay, so here a single value that average, it is single value, and this will tell us, okay, uh, the group behavior. Okay, so that we say this single value, or what you can say that average. Okay, so it is a representative value. Okay, and it is located at a central point of the series. Okay, so that's why it is known as measures of central tendency. Okay, why we call it is the measure of central tendency, center value. Okay, so it is located at a center point. Okay, so this why we always want to know this average. So here the objective is to get a single value that describes the characteristic of the entire group. That what we have talked about, the average mark or average height. Okay. So again, by taking the value of average, we can facilitate the comparison. Like that, I gave you an example that we can compare whether the students are poor in English or mathematics. Okay, so by taking that average value, that we can say in which subject the students are doing well. Okay, so here again, if we divide this the method of central tendency, there are two heads. One is the mathematical averages, other is the positional average. So coming to this mathematical average, okay, first one we can say it is there are so this mathematical average is having arithmetic mean, geometric mean, harmonic mean. Okay, so these three, and this positional average is median and mode. Okay, so first coming to this arithmetic mean. So this arithmetic mean is a very uh, popular and that widely used in the measurement of the representing the entire data by one value. Okay, so how to get that arithmetic mean? So that if you see, so let me share the screen. Okay, let me share the screen. Just one. Entire, let me share the entire screen. Can you see the screen? Just one minute. Can you see the screen? Could you please respond through chat that whether you are seeing, you are able to see the screen? So could you please respond in the chat box whether you are able to see my screen? Can you see my screen now? This Jamboard. Could anybody write in the chat whether you are able to see the screen? Please. Okay, anyway, so here, uh, uh, so now if we, okay, so now if we want to estimate, okay, so how to estimate the arithmetic mean? Okay, so here there is one direct method is there. Okay, so in direct method, now suppose if we want to know that what is arithmetic mean, uh, so here if so here it is the very simplest method. If we have 10 number of observations, okay, or if we have 5 number of observations, so what we have to do? We have to add all the observations and divide it, divide this number by the number of observations. So by taking the examples from your study material, 1.2.1 example, page number 3. Okay, here we have 5 observations: 10, 100, 1000, 10,000, and 1 lakh. Okay, so if we want to know the arithmetic mean of this series, what we have to do first? We have to add all these 5 observations, that is 10 plus 100 plus 1000 plus 10,000 plus 1 lakh. Okay, so that will be 1 lakh 11,110, and the number of observations is 5. So that is, the answer is 22,220. Okay, so that is very simple. Now suppose we have 10 observations. Okay, so that we have to simply add the 10 observations and divide the 10 divide that figure by the number of the observations, that is 10. So again we'll get, okay. uh, so if anyone could say in the chat box that whether you are able to see my screen, that I write some formula here on Jamboard. Okay. So can anybody tell me whether you are able to see my screen, because I'm sharing my total screen on Jamboard. So if you can say, that will be easier for me, that you are able to see my screen, please. Are you able to see my screen now? Okay, so here the second method is shortcut method. Okay, so here the arithmetic mean. Okay, the formula for the arithmetic mean is uh, arithmetic mean also expressed in x bar. X, that is bar, that is the arithmetic mean. So here the formula is a plus summation I will take, I is will take from 1 to n di by n. Okay, so here a is nothing but your arbitrary assume mean. So if we have some data, we can assume any value as assume mean. Okay, and di, this is the deviation is our xi minus our assume mean. Okay, so here that if you see, uh, so this is the formula. Okay, so now if we take our earlier example, that's 10, 100, okay, 1000, 10,000, and 1 lakh. Okay, these 5 observations I'm writing here, 1 lakh. Okay, and earlier we get the arithmetic mean value is 22,222. So now if you see your study material, page number 4, here how to calculate the d. Okay, deviation is xi. Okay, x is our observations 10, 100, 1000, 10,000, and 1 lakh. A is our assumed mean. Okay. So here, assume mean that you can take at your will. There is no hard and fast rule which value is A. Okay. So A you can take 10, A you can take 100, A you can take 1,000, A you can take 10,000 or 1 lakh. But what we will take assume mean, if we take the middle value of the series, so that our calculation will be very easier. So here the 1000 if you take, that our calculation will be easier. So for all x, okay, for all x, okay, let me, for here x are there. So x is 10, 100, 1000, 10,000, and 1 lakh. Okay. So D here we have to take. Okay. D is what? X I. So this is our x, all x minus A. Assume mean here we will take 1000. Okay. So for all these observations, we have to calculate the D. So x is 10, A is we have taken 1000. So 10 minus 1000, that is 9 990. Again for the second, again we have to calculate 100 minus 1000. Okay, that is 900. Okay, 1000 minus 1000, this is 0. Okay, sorry, this is minus, sorry, this is minus, this is again minus. So but we very careful. Okay, so 10,000 minus 1000, it is 9,000. Okay, 1 lakh minus 1,000, 99,000. Okay, so after getting this, we have to add all this d value, minus 990 minus 900, 0, 9,000, 99,000. So if we add all these things, that summation d, the value will be will get 1 lakh 6,110. 6,110. Okay, and here, so now this we get. Now our mean, what is the mean? The formula x bar is equal to assume mean plus sigma d by n. Okay, assume mean we have taken 1000 plus summation d, this one, 1 lakh 6,010 divided by 5. Okay, divided at 5. So here 1000 plus, so this will get 21,222. Okay, so answer will get 22,222. Okay, so whether you are applying the direct method or assuming method, the answer is same. There is no change in the answer. Okay, so this is there. So now if we want to calculate the arithmetic mean for group data. Group data means our, if we have the frequency. Okay, so frequency. So here again we have direct method and the indirect method. Okay, so for the calculating of the group data means what? Suppose you have number of classes and number of students. Okay, number of classes and your number of students, or any. So this is one example of group data. Okay, so here let us say uh, number of classes and number of students. So if it is number of classes 0, 1, 2, 3, 4, 5, 6. Here number of students is, let us say, 40, 50, 60, 70, 80, 90, 100. Okay, so how to calculate? So this is our x. Okay, number of classes is x variable. This is number of student is frequency. Frequency means how many number of students they have attended the classes. Okay. So here 40 students, they have not attended any classes. 50 students, they have attended one class. Okay. Session. Okay. Number of the counseling session. 60 students, they have attended two classes. Okay. 100 students, they have attended six classes. So here this is the frequency. Okay. So this is called the frequency. Okay. So now how to calculate the mean? So here, so if we have group data, the formula for calculating the arithmetic mean is summation. Okay. Summation I will take 1 to n fx by n, fx by n. So this is our x, this is our f, and n is the number of observations. Okay. So for this class, okay, x is equal to 0, f is equal to 40. So again, we'll calculate the fx here. Okay. F into x. Okay. F into x. Okay. So 0 into 40, 0, 50 into 200. So like that, if you calculate that, you can see here your the study material page number, what is page number here? Page number 5. Okay. Example 1.2.3. Okay. So the fx value will get 1750. Okay. 1750. And number of observations 1, 2, 3, 4, 5, 6, 7. So here number of observations. Oh, so see here, what is the number of observations? So now, so so here that earlier case we are saying the number of observations that we have taken x is equal to 0, 10, 100, okay, 1000, 10,000 like that. So at that time the number of observations was 5. But if we have uh, the frequency data, okay, group data, here what is the n? So that you have to be very, very clear. So here n is equal to summation of f. Okay, so these things you have to clear. Direct cases we can count and we'll say that is the number of observations that what we have seen earlier. Okay, earlier examples, the number of observations was 5 because x is given in a okay, 10, 100, 1000, 10,000, 1 lakh. At that time we calculated the number of observations is 5. But here we cannot say the number of observations is 1, 2, 3, 4, 5, 6, 7. So if you say n is equal to 7, that is totally wrong. So in case of group data, n is the summation of f. So here again, you have to calculate the summation of f. Okay. So if we calculate the sum, this total number of the frequencies here, it is 500. Okay. 40 plus 50 plus 60, 70, 80, 90 plus 100, it is 500. Okay. So what is the formula for calculating the mean here? Summation fx by n. So here it is mean is or the arithmetic mean is 1750. Okay, 1750 by 500, by 500. So that is the value is 3.5. Okay, I think it is clear, absolutely clear. Okay, no problem. It is very, very simple calculations. Just x is given to us, f is given, we need to calculate the arithmetic mean. So first we calculate the summation of f n. Okay, n is the, that is number of observations is summation of all the frequencies you have. Okay, and fx. So you multiply this column into this column, you get the fx by n. The value for the arithmetic mean is the summation fx by n. So 1750 over 500, 3.5. Very, very simple. No problem at all. Okay. So now this is the direct method for group data. Okay. Now again, we can have indirect or step deviation method. There is another method, that is the step deviation method. Step deviation method, or we can say that is the indirect method. Indirect method. Okay. So here the formula for the calculation of the arithmetic mean is a is nothing but I assume mean, any arbitrary value you can take. Okay. Again, that is summation ft by n. Okay, summation ft by n. So here a is the achievement d. So here d is what? D is uh, x minus a. Okay, this is x minus assume mean. Okay, by h. Okay, h is nothing but h is nothing but class interval. Okay, class interval. Okay, so that will I'll take it. Okay, I'll tell you. And so this is the d. This is the d. Sorry, this is the dx. Okay, summation f dx by n. Okay, so here first what you have to calculate? You have to calculate the d. Okay, again we'll multiply with x. Okay, you put it x, it is x. Again you take the f dx, that summation by n. Okay, so now we'll take an example. Okay, you can see. So you see in example 1.2.4. Okay, page number 6 of your study material. Okay, so there. Okay, so income is there. Income. Okay, workers. Okay, income maybe 0 to 10. Okay, so this is class interval 0 to 10, 10 to 20. No, sorry, 50 to 100, 100 to 150, 150 to 200. Okay, 200 to 250, 250 to 300. Okay, so this is income is given. Workers means your people. How many workers have income 0 to 10 rupees maybe. Okay, so here it is given. So this will be given to you. Okay, 90, 150, 100, 80, 70, 10. Okay. So we know the value of n. N is your the summation of f. Okay, so here if we add this will be, sorry, this is 10, so it's not 110. Okay. So this is 500. Okay. This is 500. So now what have to calculate? What have to calculate here? X. X is what? This is the middle value. Okay, X is calculated the middle value. Middle value means this is our class interval 0 to 10. So middle value 0 plus 10 by 2, that is the 5. Okay, 50 plus 100, this is the lower limit 0, upper limit 10. Lower limit 50, upper limit 100. Okay, so X is, we can say, lower limit plus upper limit. Okay, lower limit plus upper limit by 2. Okay, upper limit 50 plus 100, 150 by 2, 75. So accordingly you calculate for all these, it is 125, 175, 225 and 275. Okay, this is x. Now we calculate the dx. Okay, dx. It is calculate the dx. And again f dx. Okay, dx is what? dx is dx is what? That earlier I gave you that formula. X minus a by h. Okay, x minus a by h. So here x is what? X is given. Okay, x is given. X is there. This is our x mid value 575. Okay, minus a. A is again assuming. So if we take assuming is equal to 100. Okay, so now let us take a is equal to 125. Here we are taking a is equal to 125. So x is equal to 5 here. Okay, 5 minus, no, sorry, x is given. X, sorry, this is not 25. Okay, this is 25. Okay, there is some problem here. So it is, I think there's some problem. Okay. So here it is x is equal to 5. So 125, let me check, 250, 250, 125. Okay. I think there is some some printing mistake is there on the study material that will check. So this is 0 plus 10 by 2. Okay, 5 by 2. So 125. Okay, 5 minus 125 by h. It is 50. Okay, 50. 50. So it is 5 minus 125, 120 by 50. I think there is some error here. Okay. The second you take, okay, second one, this is 75, okay, 75, 50 plus 100 by 2, 150 by 2, 75. So 75 minus 125, okay, 125. So that is 50 by again 50. Okay, so it is minus 1. Okay, minus 1 again, or that f minus 1 into 150, that minus 150. Okay, so like that you'll get the f dx. So here again we take the summation of f dx is equal to 80. Okay, so after getting this, we'll that see the uh, that again will calculate the arithmetic mean. Okay, so I'm just clearing this. Okay, so here that arithmetic mean formula is summation f dx by n into h. Okay, so here it is, assume, sorry, this is arithmetic x bar is equal to arithmetic mean plus summation f dx by n into h. So arithmetic that assume mean is 125, summation f dx is equal to minus 80, n is equal to 500, okay, into 50. Okay, so here it is 117. Okay, so I think there is some the typing mistake on this solution that will rectify it. So this is the indirect method. Okay, so why this method is there are some usefulness, because it is very easy to understand and we can easily calculate. Okay, so this arithmetic mean is based on all the observations. Okay, and it is compatible with further mathematical treatment. So here, what is the further that mathematical treatment means? If we by mistakenly type, okay, or if there is some data entry error, okay, so we can rectify without calculating the arithmetic mean from the beginning. Okay, so we did not calculate fx or newly from the beginning. So if we enter any figure by mistake, that we can have it with some minor modifications. Okay, and it is least affected by the sampling fluctuations. Okay, so here the sampling fluctuations means what? Suppose here we have uh, let us say there are some uh, data. Okay, 1, 2, 3, 4, 5. Okay, if there are some the fluctuations on the sampling, if we compare two samples, so it will less affected. Okay, but there are some demerit. Demerit is what? First, it is unduly affected by the extreme value. Now, suppose what is the unduly affected by the extreme values? Now, suppose here we have this figure 1, 2, 3, 4, 5. What is the arithmetic mean here? Okay, so we have to add all these things divided by the number of observations. So, what is the arithmetic mean here? 3, 3, 6, 6 plus 4, 10, 10 plus 5, 50. 50 by your number of observations 5, 15 by 5. So arithmetic mean is 3. Okay, 3. Okay, but now instead of 5, one value is 50, let us say. Okay, or 500. Okay, that means what? If one value is 500, then our arithmetic mean value will be 510. Okay, if we add all these things, 510 by a 5, that is 102. Okay, so that means it is unduly affected by the extreme value. If we have some extreme value, our in one, so in the first instances, the arithmetic mean value is 3, when one observations the value is 5. But if that instead of 5, the observations is 500, then our arithmetic mean value is 102. But if we take other positional average like the median, okay, so here the median value will be 3. So that we'll discuss after some time. Okay, so it is the middlemost value 3. Okay, so but that even if there is some extreme value, median value will not be affected. That we will see. So it is unduly affected by the extreme value. Second one is that it cannot be calculated if the data has an open-ended classes. Okay, what is open-ended classes? Now suppose that earlier we have taken that income. Okay, income is, let us say, uh, that what we have taken. Income is 0 to 100. Okay, okay, 0 to 10. Okay, 50. Okay, so okay, so if it is 50 to 100, okay, okay, last one is 250 to 300. Okay, this is our class interval or income. Opponent classes means, suppose there is no upper limit here. Okay, if we have open-ended classes means income less greater than 250. Okay, greater than 250. Here, this is closed-ended classes, 250 to 300. So income will not cross 300. But if we have some observations like income greater than 250, that means income maybe 300, maybe 3,000, maybe 3 lakhs, maybe 3 crores, anything. Okay, so here it is anything. So on that type of classes, we cannot calculate arithmetic mean because we cannot get the middle value of the observations. Okay, so that is not possible. So here there are some limitations and we have some advantage also, but advantage is the more than disadvantage. Okay, so now coming to this geometric mean. Okay, coming to this geometric mean. So geometric mean is another method of the calculation of average. Okay, so this is geometric means. Okay, to where where we can use a geometric mean. So when we can say to measure the average rate of change over time. Okay, so now suppose if you want to know the growth rate of GDP of the country, GDP of India, okay, over the past decade. Okay, or we can say the what is the compound rate of growth of population. Okay, population growth rate. So on that case, we cannot use arithmetic mean. Okay, the population growth rate, GDP growth rate, or your that industrial growth rate, that kind of thing. Here, you have to use the geometric mean. So, that is the formula for the calculation of geometric mean. So here we have some observations. Let us say x1, x2, x3. Okay, to xn. Okay, xn observations. Okay, so the geometric mean is okay this one to the power 1 by n. Okay, so if this is the thing, then we have to take here the log value to solve the problem. Okay, so if we take the log both the side, okay, log of the geometric mean, then it is 1 by n. This, okay, this is 1 by n will come this side, log again this value x1 to xn. Okay, x1 to xn. Okay, so again, if we take the log for all this value, that is 1 by n. Okay, log of geometric mean is equal to 1 by n, log of x1, okay, log of x2 plus log of x3, like that. Okay, so the consequently we'll have log of gn is equal to 1 by will take from 1 to n, okay, log xi, okay, log xi. But if we want to know the geometric mean, then we take this log to this side, so that is the antilog of this one, okay. So geometric mean is equal to antilog of antilog of 1 by n, then summation I will take 1 to n log xi, okay, log xi. This is the formula, okay. So if you see the formula in your uh, the study material 1.3.1, the same value, okay, 10, 100, 1000, 10,000, 1 lakh, okay. So log for all the log xi 1, 2, 3, 4, 5. Again, if you take 15 by 5 is equal to 3, again we will take the anti-log of all these things. So here the geometric mean value is equal to 1000, okay. So that is the thing, okay. For continuous series also we can have this uh, value, okay. For the continuous series, the formula is, so here only thing is that what we have taken the xi value, then we'll take the midpoint of the class, that is the mi, okay. 1 by n sigma I will take 1 to n, that fi, okay, frequency log mi, okay. So that that is the same. But here the merit of this geometric mean is, it is very rigidly defined, okay. The formula is very very rigid, okay. So again it is based on all the observations, okay. So if we have two groups, okay, two groups of the series n1 and n2, we can also can calculate the combined geometric mean. So that what are the usage of the geometric mean, so that will also come in the exam. So it is that basically used to find out the average percentage increase in the sales or production or other economic business series, okay. And index number, okay. So this geometric mean is basically considered, okay, the best average in the construction of index number, okay. So that will discuss the subsequent index number. Now suppose we want to that calculate the wholesale price index or that consumer price index, that how that wholesale price index or the price index that we calculate to measure the rate of inflation in our country, okay. Maybe you're based on WPI or CPI. Here geometric mean is the best average, okay. If we use the uh, arithmetic mean, there are certain loopholes, okay, that again we'll discuss in details, okay. So where we can want to know the average percentage increase in the sales, production or GDP growth or population growth, we can use the geometric mean. Next is the harmonic mean. Harmonic mean, another type of average is your harmonic mean. So harmonic mean is what? Here it is the reciprocal of the arithmetic mean of the reciprocal of the individual observations. Okay, so now suppose we have observations, let us say x1, x2, x3 to xn. Okay, so it is the reciprocal of, okay, reciprocal reciprocal of arithmetic mean, okay, of the reciprocal of individual of the observation, okay, reciprocal of individual observations, okay, reciprocal of arithmetic mean of the reciprocal of individual observations. So that we can write in formula form, okay. Now suppose that harmonic mean is equal to, first we'll take the reciprocal of arithmetic mean, okay. Arithmetic means what? Arithmetic means x by n, okay. You have that summation x by n, that is the our arithmetic mean. Okay, so it is the reciprocal of the arithmetic mean. Okay, and by this summation of the reciprocal of individual observation. Individual observation means x1, x2. Okay, x1, x2 is our individual observation. This reciprocal, that is 1 by x1, x2. Reciprocal of x2 is 1 by x2. Okay, so it is n by 1, n by 1 by x1 plus 1 by x2 plus dot 1 by xn. Reciprocal of arithmetic mean of the reciprocal of individual observation. This is the formula for harmonic mean. Okay. So again, if we try to write in a shortcut form, that is n by summation x, sorry, I will take 1 to n, 1 by xi. Okay. So if we have some figure that earlier examples, again, if it is 10, 100, 1000, 10,000, 1 lakhs. So first the formula is uh, harmonic mean is equal to n is 5. Okay. So again we'll take 1 by 10,000. Again we'll that 5 by all these things. So ultimately the answer is uh, 45.00045. Okay, so that is there in your example study material 1.4.1. You can refer. Okay, so once you understand how to calculate the harmonic mean, it is not at all difficult. Okay, so again for the continuous series we can use the formula is that instead of our x we can use fi. Okay, and your middle value mi. Okay, so again the what are the merit and demerit of this harmonic mean. So it is also based on the value of all the observations of the data. Okay, it is less affected by the extreme value. Okay, so now if we have some extreme value that 1 lakh. Okay, so why it is not affected by extreme value? Because we are not taking the direct value of 1 lakh, but we are taking 1 by 1 lakh. So again, if we take the reciprocal, okay, it is strictly defined. The formula is very strictly defined, so there will not be any problem. Okay, but what is the demerit? Okay, so again, it is not easy and simple to calculate this harmonic mean because first we have to take the reciprocal of the observations. Again, we will take the reciprocal of the arithmetic mean. So it is very complex. Okay, so that not like your our the arithmetic mean calculations. Okay, next one. So see, if one observation is zero, so we cannot calculate, okay, the harmonic mean because 1 by 0, okay, that is not defined. Okay, so if one observation is not positive integer or if it is 0, we cannot calculate the harmonic mean. That is the demerit of that harmonic mean. So till now that we have where you can use, okay, so that another uh, demerit of that harmonic mean is it is always less than arithmetic mean and the geometric mean. Arithmetic mean and the geometric mean. And where you can use, next is a usage, where you can use the harmonic mean. So here, if you want to calculate the average, okay, but two units are involved, like rate and speed. The rate at which the train is moving, okay, or the speed at which the car is going. So average speed, okay, if you want to know what is the average speed of the car, okay, two cars, okay, we can use the harmonic mean. So now that another important questions that till now what we have discussed the arithmetic mean, okay, geometric mean, harmonic mean. So arithmetic mean, harmonic mean, and geometric mean. Okay, so here there is one the mathematical relationship. Arithmetic mean is greater than or equal to geometric mean, greater than or equal to harmonic mean. Okay, so in this context, okay, the equality conditions will be the relevant even only if all the observations in the series are equal. Okay, so if all the observations in the series are equal, so that at that time we can have the arithmetic mean is equal to geometric mean is equal to harmonic mean, but it's not same in real life scenario. Okay, if we have two positive numbers xy, if it is x is equal to y, then only we will have. But if it is x is not equal to y, then this will valid. Okay, this will valid. So that proof is also there. Okay, so you can see that arithmetic mean you have, if we have x and y, two, arithmetic mean is equal to x plus y by 2 if there are two series. Geometric mean is equal to root of xy. Okay, and the arithmetic mean is equal to sorry, that harmonic mean is equal to 2xy by x plus y. Okay, so the proof we can have. Okay, that is there in your study material. Okay, so that proof also you can have how that arithmetic mean is equal to greater than or equal to geometric mean or greater than or equal to harmonic mean. So it is easy. So they have taken x minus y square is equal to greater than or equal to 0. So again, you can prove it. Okay, so the arithmetic mean is equal to greater than geometric mean, and again you can geometric mean is equal to greater than or equal to harmonic mean. Okay, so that you can see by taking one example also that you can verify whether this the relationship was true or not. Okay. So till now we have discussed the various uh, that all the definitions of arithmetic mean, geometric mean, harmonic mean, and by taking the simple examples how to calculate by using direct method and your step deviations method uh, that we have done. So now coming to this positional average, okay. So arithmetic mean, geometric mean, and harmonic mean are all your the mathematical average. Okay. Coming to this positional average, there are median, okay, median and mode. Okay, on the median again we have quartiles, deciles, okay, median, median, okay, quartile, deciles, percentile, okay, mode. So coming to this median, uh, median is the positional average. Okay, that means which divides the data into two equal parts. Suppose now we have this data. Okay, let us say 0 to 100. Okay, 0 to 100. So so it will divide the data into two equal parts. Two equal parts. Okay, two equal part means median is the middle most value. Okay, middle most value. So this is if this is what is the middle most value? 50. Okay. If we have 0 to 100, so this is our first part. Okay. Again, this is the second part. So equal two parts, the median divides the data into two equal parts. So here in our case, the value of the median is 50. Okay. But here, one thing you have to uh, keep in your mind. Okay. So we have to uh, first arrange the data in either ascending order or descending order. Okay, if a data series is given, if we simply calculate the median, the middlemost value, then it will be wrong. So first either we'll arrange the data in an ascending order or descending order, then only we can uh, calculate the value of the median. Now, if we don't arrange the data in either ascending or descending order, then what type of problem we will have? Now, let us see. Now, suppose we have data of, let us say, 5 to 38, okay, 40, 8, 9, this is 40, okay, and 100. Okay. So now, if we have what is the middlemost value here without arranging, the first is 5, 2, 38, 40, 8, 900. So 1, 2, 3, 4, 5, 6, 7. So here the middlemost value is 1, 2, 3, 4, 40. 40. 40 is the middlemost value without arranging the data. Now, if we arrange the data in an ascending order, so first is 2, then 5, then 8, then 9, then 38, then 40, then 100. Okay, if we arrange the data in an ascending order. So now, what is the middlemost value here? 1, 2, 3, 1, 2, 3, 9. Okay, so actually the value of the median is 9. But if we calculate without arranging in a descending order or in ascending order, the median we calculated is 40, which is totally wrong. Okay, so this is ascending order. Now, if we arrange the data in descending order, so it is 100, 40, 38, 9, 8, 5, 2. Sorry, 2. Okay. So see, now again, the value of the median is first 3 is gone, last 3, again it is 9. Whether you arrange the data in an ascending order or a descending order, okay, the value of the median will remain the same. Okay. All right. So this is the there. Okay. Uh, so now, so uh, so now, if we have some uh, so if we have data of odd number, okay, odd number, okay, so it is odd 1, 2, 3, 4, 5, 6, 7. So what is the value of the median? N plus 1 by 2. N plus 1 by 2. So it is 8 by 2. That is the fourth value, fourth position. Okay, fourth means this is 1, 2, 3, fourth. Fourth position of the item, that is 9, is our median. Okay, if we have some even number n by 2. Okay, if we have some 8 observations, okay, so that is the uh, n by 2. So now, if we have some, how to calculate the mean value of group data. Okay, so it is, if we have simple data, we can calculate. Now, suppose if we have, just let me see. Okay, so if you have any query that you can type in the chat box. Okay, so now you have some group data. Okay, group data means, let's say, uh, okay, income and number of persons. Okay, now suppose we have income and number of person. Okay, number of person is our frequency. Okay, okay, so here I'm taking the example of, let us say, example 1, page number 18. Okay, so uh, below 10, below 20, below 30, below 40, income is in 1,000 rupees, below 10,000, below 20,000. Okay, so now if we have that kind of thing, below 10,000, we can have 0 to 10,000. Okay, so this is income in 1,000. Income is measured in 1,000. Below 10,000 means 0 to 10. How many number of, so number of persons in 100. Okay, 200 persons. Okay, number of person is 100. Okay, below 20. Okay, 0. Sorry, below 20 means that is 10 to 20. Okay, 10 to 20,000. How many people? 300 people. Okay, 300 people. Then 20 to 30. Okay, 400 people. 30 to 40. Again 300 people. 40 to 50. 200 people. Okay, 50 to 60. 100 people. 60 to 70. 50 people. Okay, 50 people. Okay, so it is n is, sorry, this is 0.5. 0.5 means if you are taking 100, so it is 50. 0.5. So n is equal to summation of f, that is 15.6. Okay, 15.6 means 15.6 what? 1560. Okay, that is the n. Okay, so here here, but how to calculate the mean here? Okay, so here the formula for calculating the mean is your, sorry, the median. Okay, calculating the median is L1, okay, plus L2 minus L1 by F, okay, into M minus C, okay, M minus C. Okay, what is L1? L1 is a lower limit of the median class, okay. L2 is upper limit of the median class. L1 is the lower limit of the median class. F is the frequency corresponding to the median class. M is n by 2. M is n by 2. N is your this one, summation F. Okay, summation F by 2. Okay. C is the cumulative frequency of the class preceding the median class. C is the cumulative frequency, okay, of the class preceding the median class. Preceding the median class. So here we have to calculate another type of your column, that is a cumulative frequency. Okay, frequency is given, we have to calculate the cumulative frequency. So from income 0 to 10, the frequency or the total of that cumulative frequency is 2. Okay, for 10 to 20, cumulative means we have to add all the frequency. 2 plus 3, here it is 5. Okay, 5 plus 4, 9. 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 15. 15 plus 5, okay, 15.5. Okay, another column is there, I forgot. 70 or more, okay, 70 or more, that we can say here 70 or more, 70 or more, okay, 70,000 or more income, that is 0.1. Okay, so it is 6, 15.6. Okay, so this is the cumulative frequency. So now how to calculate this median? Okay, so here you see 15.6. Okay, 15.6 we got. Now what is the n here? N is n by 2. 15.6 by 2, 8, 7.8. Okay, so now n is what? 15.6 n by 2. Okay, 15.6, 7.8. Okay, now we'll see in the column of the cumulative frequency whether 7.8 is there. Exact figure is not there. 7.5 is there or no, it is not there. 5, 2, 5, 9, 12. Okay, so 7.8. So if this figure is available, that class will be the median class. If that is not available, we'll take the immediate higher figure from the 7.8. So immediate largest figure from 7.8 is 9. Okay, 5 we cannot take because 5 is the smaller than 7.8. So here the median class lies in the class 20 to 30. Okay, median lies in the class, okay, 20 to 30, corresponding to this 9, that cumulative frequency, which class it is. So here we can say the median lies in the class 20 to 30. Hello? Okay, all right. Median is not 20 to 30, but the value of the median that lies in the class 20 to 30. So now our lower limit and upper limit. L2 is our upper limit. So upper limit is 30, lower limit is 20. So in our case, L1 is 20, L2 is 30. Okay. So now everything is clear. So now how to calculate the median? So now let me clear this. Now let me write L1 is 20, lower limit of the median class. L2 is 30. Okay. Then what is what is the formula? What is the formula? Median. Median is our L1 plus L2 minus L1 by F M minus C. Okay. L1 we know, L2 we know. Okay. L2 we know. Next is what is F? Frequency of your that median class. So 9 it is the cumulative frequency 9. So corresponding to the median lies in the class 20 to 30. So F is 4. Okay, corresponding to this median class, what is the frequency? That should be the F. Okay, okay, and that preceding class frequency. Okay, so now it is 20. L1 is 20 plus L2 is okay. L2 is 30 minus 20. 30 minus 20 divided by 4. Okay, m is 4 into I'm putting m is 7.8 minus c. C is what? C is what I told you. C is your cumulative frequency of the class preceding the median class. Okay, median class is 20 to 30. Okay, so preceding that cumulative frequency you write that is 5. Okay, so you have to be very careful what is the value of the C. Okay, C is what? The cumulative frequency of the class preceding the median class. So preceding the median class, that class is 10 to 20. So corresponding to the 10 to 20, that you have to take the cumulative frequency of that value. So at the in our example, it is 5. Okay, so you have to be very, very careful what is your that C. Okay, so that is the 5. So if you solve all these things, that you will get the value 27. Okay. So this is our median value. Okay, so just to practice, and if you have any query that you can ask me, okay, in the next class. Uh, so that is the thing. Okay, so it is so. So here that one important property, okay, the sum of the deviations of the items from the median, okay, that ignoring the sign should be the least, okay. So if you take the deviations of item from the median, okay, if you ignore the sign, that is that xi minus md, that should be the least. So what is the merit of this median? So it is the if we have open-ended classes. So in our example, if the income is that greater than your 70, okay, 70,000, okay, so that is open-ended classes. So in case of open-ended classes, we can calculate the median, okay. It is also not affected by the extreme observations, okay. So again, the value of the median is we can determine graphically, okay, but the value of the mean we cannot graphically uh, determined. Okay, so it is easy to calculate and understand the median. Okay, but the demerit of the median, it is that we have to arrange the data either in ascending or descending order. If you cannot arrange the data in ascending or descending order, okay, so again our whole calculation will be totally wrong. Okay, and it is not determined by all the observations in the series. Okay, so it is not determined by all the observations of the series. So that means what? Okay, so now that we will give some example. Let us say if this is the data 2, 3, 4, 5, and 8. Okay, so what is the value of the median? It is the middlemost value 1, 2, 3, 4, 5. So 5 plus 1 by 2, that is the third item is our median. So this is the third item. So it is the 4. 4 is our median value. Now that instead of 8, if I have 8,000, okay, again the median value will not change. So that instead of 2, if it is the value 0, if it is 1, 1 also it will not change. Even if it is 6, the value will not change. If it is from 80 lakhs also or 8 crore, median value will not change. That means median is not uh, calculated by the all observations in the series. It will not take all the observations. But if you calculate the mean, again, if there is any extreme changes in one value, extreme value, that will affect the average mean value, arithmetic mean. Okay. But here again, that median is not capable of further algebraic treatment. Okay, so if we have done any of the calculation wrongly, we cannot manipulate the calculation. Again, we need to calculate the median from the beginning. But in case of arithmetic mean, there is no need of again calculation of the arithmetic mean. Okay. Uh, but again, the sampling stability of the median is less as compared to the mean. If there is any fluctuations in the sampling, again, the value of the median will fluctuate a lot. Okay. Now, coming to the next quartile. Okay. Quartile. Okay. QARTIL. Quartile means what? We can divide the items into four equal part. Quarter. From quarter, it is quartile. Okay. So if we have observations, okay, so if we have, let us say, this one, okay, from the, if this is the quarter one, okay, this is the quarter two, this is quarter three, okay, this is last quarter. Okay, so four equal parts. Okay, four equal parts. Okay, first quarter one, this is quarter one, quarter two, quarter three, quarter four, four equal parts. Okay, four equal parts. Okay, quarter one, this is quarter two, this is quarter three, this is quarter four, four equal parts. Okay, four equal parts. So here, or that we can say the first quarter is Q1, first quartile, or we can say 25% of the data. Second quarter, again, 25% data. Okay. This is 0 to quarter one, quarter two, quarter three, last quarter. Again, 25% of the data. This is again 25% of the data. Again, this is 25% of the data. If we have 100% data, okay, we can divide into four equal parts. Okay. So how to calculate this quartile? Okay, quartile. So this is quarter two. Quarter two is 50%, first 50%, then second 50%. So Q2 is our nothing but our median. Okay, median also will equal that. So this is our median. Okay, so for this the calculation of the quartile, okay, the formula is here: lower limit plus upper limit minus lower limit by f. Okay, and if we have n by 4 minus c. Okay, that cumulative frequency. Okay, I into n, okay, by 4. This is I minus c. Okay, I will take from 1 to 3 because there are three part. I will take from 1 to 3. So L1 is our lower limit of the first quartile class, ith quartile class. Okay, L2 is the upper limit of ith quartile class. C is the cumulative frequency of the class preceding the ith quartile class. M is the frequency of ith quartile class. Okay, so if you because of the time constraint that we are not able to solve how to calculate the quartile, but you can follow some actually book or something. There you can see how that how to compute the quartile. Okay, so now that quartile, there is another concept that is decile. Decile means we can divide our entire data into 10 equal parts. Okay, decile 10 equal parts. Okay, like d1, d2, d3, dn. Okay, 10 equal parts. d1, d2, d3, like d9. Okay. So decile. So this will remain the same. Only thing is that here, that instead of 4, we can write the 10 equal parts. Okay, we have to uh, see. Okay, we have to uh, divide our data into 10 equal parts. Okay, like the decile, there is another concept, percentile. Okay, percentile means we'll divide our entire data into 100 equal parts. So the formula again remains the same. Instead of n by 10, we can divide the n by 100, that is the percentile. Percentage, I mean, so that what we call it percentage. Okay. So again, this quartile, decile, percentile. Okay. Again, uh, we can have, if we have some open-ended classes, also we can calculate the percentile, decile, percentile. Okay. So if there is some absence of data, also we can calculate. Okay. But again, this is extreme value that will not affect our quartile, percentile, decile, and this again we can locate all this data in a graph form. Okay. But the demerit is that it is very difficult to understand by common man. So we cannot convince a man, common man, okay, how to calculate the percentile, decile, okay, decile, percentile, quartiles, okay. And it is not based on all the observations of a series. So now suppose if we have the quartile, okay, we'll divide the data into three four equal parts, okay, first quarter, second quarter, third quarter, fourth quarter. So only we can calculate what is our quarter one, quarter two, like that. But here, yeah, this value that will not have much significance. Okay. So again, again this quartile, percentile, decile, if the data are there, okay, uh, and if we don't arrange the data in ascending or descending order, again, here also we have to take arrange the data in either ascending or descending order. So without ordering, we cannot compute the percentile, quartile, and decile. Okay. And again, this all these positional leverage, okay, they have less sampling stability. Okay. There is another concept, okay, that is the OG. OG. OG means what? Here, we can OG. So it is a graphical way we can OG, OGI. Okay, OGI is a graphical information. Okay, that will show our that cumulative frequency. Okay, construct an OGI. So first, if the data is given, okay, first we have to make the cumulative frequency table. Okay, if some data is there, if X is there and F is there, okay, so we have to make the cumulative frequency. Okay, and here there are two type of the frequency. Okay, one is the less than OG for, one is more than OG for, more than OG score. Okay, less than means what? That if we start from the lower limit of the class interval and then subtract class frequencies from the cumulative frequency, that type of frequency is known as your uh, less than OG. Okay, and if we see that if we plot, so that will be illuminated S tone upside down. Okay, upside down. Okay, less than OG, which looks like an illuminated S curve. Okay, so this one is one, and okay, so less than frequencies, less than and the more than OG. Okay, so this median, okay, whatever we can discuss. Okay, so that median we can have like we can show this median like less than OG and more than OG. Okay, so here if we want to show this, just just give me a minute. So this OG also you can show like this, and one you can show like this. Okay, so if we plot these two curve, uh, more than OG and less than OG, this middle portion is our median value. So that is all about this usefulness of the uh, OG. Okay, more than OG means that if we start from the lower limit class and interval and then subtract the class frequency of the cumulative frequency, we have more than OG. And if we have start from the upper limit of the class interval, then the class frequencies get cumulative frequency. Okay, so this is the way. So we can have the frequency. And uh, lastly, the last position, that positional average, is our mode. Okay, what is the mode? Mode is the value of the variable, okay, which occurs the most frequently data. Okay. Now suppose if we have a uh, marks, okay, obtained by the student, okay, if we have some data, okay, of the marks obtained by the student, let us say 28, 40, 35, 82, okay, 65, 65, okay, 39, 66, 65, 70. If we have marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 students marks are there. Okay. So what is the mode here? So mode is what? The value of the marks. Okay. So which marks occurs the most frequently data? Which marks is obtained most by the most student? Okay. So now again we'll see 38 only one number, 40 only one student, 35 only one student, 82 only one student. Okay. 39 one student, 66 one student. Suppose another 66 is there. Okay. 66 two students, 65 one student, seven sorry 65 three students. See 65, 65, 65, 71 student. Okay. So 66 two student, 65 three students is secured by only one student. Okay. So here 65 occur the most frequently. Okay. So here value of the mode is 65. Okay. Which variable has occurred the most of the time? That is mode. So here in our example, the marks, it is three times has occurred. Three students they have secured 65 marks. Three students. Okay. So the value of the mode is 65. Okay. So again, if we have some group data, okay, group data, we can also calculate the value of the mode. Okay, value of the mode is equal to L1 plus our F1 minus F0 by 2F, 2F1 minus F0 minus F2. Okay, so another formula is L1 plus delta 1 by delta 1 plus delta 2 into I. Okay, so here Li is lower limit of the modal class. Okay, okay. F1 is the frequency of the modal class. F0 is the frequency of the class preceding the modal class. Okay, and if you take the delta 2, okay, delta 2 formula, delta 1 and delta 2. Delta 1 is F1 minus F0. Okay, delta 2 is F1 minus F2. Okay, F1 minus F2. Okay, so it is uh, that also it is that you can take if you have some SQ or through some the internal Google also we can have some examples how to solve. Okay, so you can try it out. Okay, so now that we will see that what are the merit and demerit of the mode. So it is easy to calculate and simple to understand. Again, it is not affected by the extreme values. Okay, we can also uh, present the mode the graphically. Okay, and if you have some open-ended classes, okay, that we can also have mode. Now suppose if we have examples like less than 10 marks, less than 10, okay, other class is let us say 10 to 20, 22. This type of data also we can calculate the value of mode, but we cannot calculate the value of arithmetic mean. Can be anything 0, 1, 2, 3 up to 9. Okay. Above 30 means that marks can be anything. Okay, maybe 35, 98, 78, anything. Okay. But here the demerit is that it is not possible to further algebraic treatment. Okay, and the value of the mode cannot always be determined. Now suppose we have a class like this. If we have a data series like this, 3, 2, 3, 2, 5, 6. What is the mode? What is the mode of this class or of these observations? Because here 3, the frequency is 2, 3 has occurred 2 times, 2 has occurred 2 times. So what is the mode? That we cannot say mode is 2, that we cannot say mode is 3. Okay, so that type of class we can say it is a bimodal class. Okay, the value of the mode is 2 also, 3 also, because it is the equal. Okay, so it is not always determined value. So the mode of the value of the mode we cannot always determine. Okay, so it is not based on each and every item of the series. Okay, again, now suppose again if it is 3 here. Okay, so if we have data like this, so the value of the mode is 3. Now suppose instead of 5 if we have 50, again the value of the mode is 3, it will not change. Okay, if instead of 1 2, if the value is 12, okay, again the value of the mode is 3. Okay, so it is not based on all and every item of the series. Okay, there is another that important relationship between this mean, median, and mode, so that you need to remember. Okay? So it is the mode is equal to 3 median minus 3 median minus 2 mean. Okay, 3 median minus 2 mean. So now if the question is given to you either median and mean, that you can easily calculate the mode. If the median value is, let us say, 20 and the mean value is 12, okay, what is the mode? So mode is equal to, let us say, 3 median. Okay, this is our median, this is our mean. Okay, 3 median. Okay, 20 into 3, 60 minus 2 mean, 24. So it is 36. Okay, 36. So now if mode is given and median is given, you can calculate the value of the mean. So it is, so these things you need to remember. Okay. Now coming to this that measures of the central tendency, that is positional average. Okay. Uh, again here, uh, see now again only that what I told you, only the value of the median, if sorry, only the value of the average value, we cannot say or we cannot comment about a series. Now suppose uh, now suppose this is all about the dispersion. Okay, now it is all about it is not only the value of the that average we can comment. Okay, now there is another thing, that is dispersion. Why the dispersion is having its own advantage. Now suppose that if I give some example, there are two players, player A and player B. They have played some the cricket matches. Okay, so this is a typical example of a or a textbook example. Now suppose that player A, okay, I think most of you are interested in the cricket. Now suppose that player A and player B, and they have played 5 games of cricket. Now suppose that player A has scored in one game 100, other games 100, okay, others game 99, another game 101, other game 100. Okay, the player B has, he has also played some game, and let us say in one game he has secured 280. Other games he has secured 0. In other games he has secured 1. In other games he has secured, let us say, uh, 200 and uh, uh, 9. Okay, 209. Okay, and another games he has secured 10. Okay, so here the average value, if we want to calculate, okay, the arithmetic mean value for both the player, how much it is? Again, it is 100. Here it is 100. Okay, so based on this uh, average, Okay, the arithmetic mean both the player are equal because we can comment that their average run score in the two games is 100. Both are same, but does it indicate that both the players are equal? No, because you see, the player A is a stable player and player B is a unstable player. In one game, he has scored 280, and in one game, he has out knockout. Okay, without scoring a run, he got out. Another matches he had secured one. But if the captain is playing, let's say World Cup final, so which player he'll choose? That obviously player A, because if the player B will click, that player B only can win the match. But if he flops, scored zero, the whole team will collapse. Okay, so instead of choosing the player B, the good captain, he'll choose the player A because he's a very stable player. Okay, at least he has the captain will have some faith. At least he'll score one century. Okay, so that will uh, limit the pressure to other player. So here, so this is one dispersion. So why this dispersion, or let's say uh, why? So here it is dispersion means what? We'll take. So what is the dispersion? So this from this average value mean what is the dispersion of what is the dispersion of that other value. So 100 minus 100 it is 0. 100 minus 100 it is 0. 100 minus 99 it is 1 minus 1. Okay, 100 100 and so this minus 100 99 minus 100 minus 1 101 minus 100 plus 1 it is 0. Okay, so this one 280 minus 100 180. Okay, 0 minus 100 minus 100 1 minus 100 minus 99. Okay, it is 109. Okay, it is 10 minus 100, it is minus 90. So this data is dispersed widely. Okay, there is a great deviation. Variation is very large in case of player B, but variation is very less in case of the player A. So it is the so from this the measures of the central tendency. Okay, we cannot tell about the data. So this dispersion is measured the variation of the item. So here the variation is very less. That's why we call the player A is stable one. But here the player B, the variation is very large, minus 100 plus 180. Okay, so here the variation is very large. Okay, so it is the dispersion. Okay, dispersion is the measure of the variation of the items. Okay, so there are here we have various various types of the variation or the dispersion. One is the range. Okay, range, mean deviation. Okay, standard deviation, quartile deviation, variance. Okay, so these are all. There are two types of variation. One is the absolute variation. One is the relative variation. Okay, relative variation. So that we'll see. So coming to the range. Okay, so first is the range. What is the range here? Range is nothing but the value of the range is your the difference between the highest and the lowest items of the observation. Okay, if we have two value, okay, highest value and the lowest value. Okay, so now suppose you have data. Let us say 1, 20, 30, 90, 100. What is the value of the range? 100 minus 1. Highest value is 100, lowest value is 1. That is 99. So here the range, okay, it is the measure of dispersion, the simplest measure of the dispersion. The range value is 99. So this is the absolute value of the dispersion. Okay. So here the relative measure, you can say coefficient of range. Okay, so it is the merit of the range. Uh, it is very easy to calculate. Okay, uh, and its value will increase with the increase of the size of the sample. If here we have the number of the observation is 5, if the sample size that increase, now let us say if it is 200 or it is 250, again the value of the range will increase as you increase the sample size. Okay, and it is simple to understand and that easy to calculate range. Okay, now coming to the next one, the mean deviation. Okay, so it is mean deviation is deviations of the items. Okay, second one is the mean deviation. Okay, it is calculated by the observations from their mean. Okay, deviations from their mean. How that that we have taken one example of that player. Okay, mean value was 100, and we have calculated what are the deviations from their mean. Okay, so if we add all these things, okay, so here their algebraic sums will be zero. Okay, if the deviations of all observations from their mean is calculated, so deviations from the mean, okay, their algebraic sums will be zero. But if the sum is not equal to zero, then it is that impossible to get the average of the deviations. Okay, so here how to calculate the mean deviations? It is the formula is 1 by n. Okay, uh, 1 by n mean deviation. It is 1 by n that summation x minus your x bar. Okay, the absolute value you have to take. Okay, absolute deviations. Okay, so if we have frequency, okay, if we have frequency, then we have the frequency data. Okay, 1 by n. Okay, and your fx. Okay, fx. X is again the absolute deviations. Okay, absolute deviations you have to take. Okay, n is the number of observations. Okay, so now if you take 32, page number 32, there is one examples is there. Okay, so that you can see class from 0 to 10. Okay, let me share the screen here. Okay, so I think you can see from classes there 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, frequencies are given. Then again you have to calculate the mid value, then x minus x bar, then fx, then fx, okay, mod value. Okay, so it is simple that you can calculate fx. Okay, fx by n. Okay, due to some time constant, we are running short of time, so I'm not able to solve on the screen. Okay, so that you try it out. Okay, now it is the standard deviation. Next is the standard deviation. You try that solving the then make a problem. If you have any doubt, you can type on the chat box. Then I'll try to solve your query. Okay. Next is the standard deviation. Okay. Standard deviation. It is based on all the deviations of so from the arithmetic mean. Okay. So it is the best used measure of dispersion. Okay. So the basic formula for the standard deviation is the summation. Okay. X minus mu square by n. Okay. Uh, that is, so this is summation we put here, summation of x minus mu square. This is the standard deviation. So x is an so it is capital X. So this is capital X minus mu. So x is the observations. X is the observations. Okay. Mu is the arithmetic mean. Okay, n is the number of observations. Okay, in some uh, books that you can have capital X minus x bar square by n square root. Okay, so mu and this mean both are same. So okay, so here mu is our arithmetic mean. So it is the only the symbol how we can express the arithmetic mean, n is the number of observations. Okay, so that is the simple formula. Okay, and here, this is the you can say the population standard deviation. Okay, and that is sigma. Okay, so this standard deviation is also expressed in the symbol Greek letter sigma. Okay, sigma means the standard deviation. Okay, so here, if we have how to compute, okay, if we have the frequency data, okay, so there are other also that you can have shortcut method. There are various method for uh, to calculate the standard deviation. Okay, so that you can use that other formula also. The standard deviation is equal to I, okay, uh, I into square root 1 by n, okay, that summation f d square minus summation ft square by n. Okay, so if we have let us say given some data, okay, of the frequency data. So suppose 0 to 10, 10 to 20, 20 to 30, then frequencies are given. Okay, so you can refer the page number 35. Okay, 35 of the 35 of your study material. Okay, so let me share the screen. I'll share the screen. Just give me 1 minute. Okay, present, share screen, window screen. I'm just sharing. Okay, I think can you see the screen? Let me give you this one. So this is the this example I'm just telling to you. Okay, so this is your class. Okay, this is frequency, this is mid value. So this is the class 0 to 10, 40 to 50. Okay, all are frequency. Again, you find out the mid value 0 to 10, 5, 10 to 20, 15, 20 to 30, 25, 30 to 40, 35, 40 to 50, 45. Mid value you can 0 plus 10 by 2, 10 plus 20 by 2. So next is deviation, x minus a. Okay, x minus a. What is x here? So x is our mid value minus a. Okay, a you take any of these things, assume mean, that is up to you. So here we have taken assume mean is equal to 20. Okay, so it is 5 minus 25. I think I assume you have taken 25. So 5 minus 25 minus 20, 15 minus 25 minus 10, 25 minus 25, 0. Okay, D or D. D means this will, what is the D value? This you can check here. D is your that class interval. D is x minus a. Okay, by n. So here D is, we have divided by 10. Okay, d by I is our class interval. Okay, d is minus 20, class interval is equal to 10, 0 to 10, 10, 10 to 20, 10. So 20 by minus 20 by 10 minus 2 minus 10 by 10. So 10 is our class interval, I is interval. Okay, same the equal interval. And f into d, f is our frequency f, 1 into d minus 2, 5 into 0 0. So this is fd the square. Fd means whole square. So it's minus 2 into minus 2 4 minus 3 into I think there is some problem here. It should be 9. Okay, one it should be 9. Okay? There is some problem here. Okay, this should be, sorry, fd square d. Oh, okay, sorry, this is d square, fd square. So this will be 16. I think there's some problem. We'll check it out. Okay, so ft square d square. Okay, okay, fine. So see here how it is coming. FD, this is FD, then FD square. D is minus 2 into minus 2, 4, 4 into 1. See, this is F. Okay, correct. 4 into 1, 4. Okay, F is, F is 3 here. D is minus 1 into minus 1 plus 1 into 3, 3. Okay, 0. So here it is. D is plus 1, 1, 1 into 4, 4, correct, it is correct. So FD square is 19. So by just I is our class interval 10, so 10 square, FD square is 19, okay, 19 minus FD the square, so this is 3, 3 square, N is our 15, summation of N, so we will get 1854. This is our summation fx square. So this population mean will get the simple standard deviation fx square by n minus 1, 14. So it is uh, 11.46. Okay, the sigma is 11.07. Simple standard deviation. It is s minus 1 we are taking, so it is 11.46. Okay, so this is all about the formula. Okay, so uh, let me present. Okay. Jumbo screen. Okay, let me Jumbo. Okay, so see this standard deviation. It is rigidly defined. Okay, and it based on the items of all the observations. Okay, uh, until okay. So this is all the things. Okay, so it is if all the variate values are the same, then standard deviation will be zero. Okay, and the standard deviation is least affected by the fluctuations of the sampling. Okay, so if all the variations are equal, okay, now suppose if we have suppose that we have taken the player A. If the player score in all the game 100, okay, and here 5 games, so here average the relative mean value is 100. So here the standard deviation is 0. Okay, that is because here the mean value and all the observations are equal, so there is and the standard deviation will be 0, and it is affected by the change of scale, but not affected by the change in the origin. Okay, so where you can use the standard deviation, this is one that important implication. Uh, so like in the competitions of various statistical technique like the regression coefficient or the correlation coefficient, we can use the standard deviation. Okay, so it is also a reliable uh, testing device for to measure the dispersion of the series. Okay. Next is quartile deviation and semi-quartile range. Okay. So quartile deviation. So earlier we have seen that quartile. Okay. So quartile deviation is Q3, okay, minus Q1, third quarter minus first quarter by the 2. Okay, so it is the lower quartile, it is upper quartile by 2. Okay, quartile deviation. So it is the relative measure of the, uh, the dispersion or the quartile deviation. So it is 2 by 3 into standard deviation. Okay, if the standard deviation is given, value of the standard deviation is given, we can calculate the quartile deviation, that is 2 by 3 standard deviation. Or if the value of the quartile deviation is given, we can calculate, if the standard deviation is given, we can calculate the quartile deviation by multiplying the standard deviation by 2 by 3. Okay. Uh, That another types of that measure of dispersion is your variance. Variance. Variance is the square root of the standard deviation. Okay. Square root of the standard deviation. Square of uh, the standard deviation, not square root. Okay. So we can say the standard deviation is the square root of the variance. Both are the same. Okay. Square root of variance. Okay. Square root of variance. If the value of the standard deviation is, let us say, 2, okay, variance will be 4. Okay, or if the variance is 4, the standard deviation is the square root of variance 4. It is 2. Okay, it is simple. Okay, so that measure of your range, mean deviation, standard deviation are your absolute measure of dispersion. Okay, now coming to the uh, your the relative measure of dispersion. Okay, relative measure of dispersion. That is coefficient of dispersion. Okay, coefficient of dispersion means your uh, measure of dispersion by the relative measures of central tendency. Okay, that is measure of dispersion by the relative measures of the central tendency. Okay. Now another concept. It is very very important. Coefficient of variation. Coefficient of variation. Coefficient of variation. Okay, that is CV. We can say coefficient of variation. The formula is standard deviation SD. Okay, by arithmetic mean into 100. Okay, if the value of the standard deviation, or you can say sigma by mean x bar into 100. Symbolically also you can express. If the value of the standard deviation and mean is given, we can easily calculate the value of the coefficient of variation. If suppose the standard deviation is 2.5, okay, and the arithmetic mean is 1, we can say the coefficient of variation is 2.5. Okay, like that you can calculate. Next is another is your standard error. Okay. Standard error. So what is standard error? Here, the standard deviation, okay, of sampling distribution of a statistic, okay, is known as the standard error of that statistic. Okay. So, uh, standard error that we can say it is expressed as standard error of your mean. It is expressed as sigma by root of n. Okay, root of n. Another concept is your probable error. Okay, so this concept you need to understand. So these you can use in the subsequent chapters. Okay, probable error. So here the probable error it is the quartile deviation of the sampling distribution of mean. Okay, so probable error is this value you need to remember 0.67449 into standard error okay, things to remember. Okay, so basically the so this person has no particular advantage. Okay, and moreover so this the troublesome factor 0.67449. Okay, so but here that is the file. So it is gone out of use and given place to the standard error. So this is error that most people don't use this the probable error kind of thing. Okay. So now there are some examples up there in your study material, page number 39. Okay, you can practice it. And next, the last portion is the squareness and hypothesis. Okay, so I'm just sharing this study material that will be Let me share the screen. Let me share the screen. I think you are able to see the screen here. Okay. So the last portion is okay, squareness and kurtosis. Basically, it is squareness and kurtosis. Again, the measures of the central tendency, average, or your the dispersion, they cannot tell details of a particular data series. So how these data are dispersed? Okay, so that another measures. Okay, uh, whether that degree of symmetry or the flatness of the mode with the help of that squareness and kurtosis, that you can say how that data, okay, are symmetrical or the asymmetrical. So now here that squareness means the degree of asymmetry. Now if you see this diagram, okay, so this is your asymmetrical. So that means the middle of this, it is mean, but it is uh, negatively skewed, okay, negatively skewed, and it is positively skewed. So mean is like here, okay, so not it is here, this is asymmetrical, this is again it is that asymmetrical. So here uh, negatively skewed, so this is the negatively skewed, it is the positively skewed. Okay, so when we have a positively skewed distribution, okay, like this, so here arithmetic mean is greater than the median and greater than the mode, and a negatively skewed distribution, okay, that arithmetic mean is less than median and less than mode. Okay, that is the thing we have to understand. So another thing is that kurtosis. So kurtosis is the flatness, okay, flatness of the move. Okay, so if you see this diagram, okay, this is different. So these are not same shape. The leptokutic, okay, there are mesokutic, latokutic. So if we have some uh, flatness, you can see here. So this is the top. Again, this is second one. If it is less, and the third one is the platoputic. So that if the depending on the value of the beta two, if it is three, you can say mesocutic. If it is greater than three, leptocutic, and if it is less than three, you can say platocutic. Okay. So how to measure the squareness? Squareness is like quarter three plus quartile three plus quartile one minus two into median. Okay, that is your uh, that absolute measure of squareness. Okay, so that for a positively skewed distribution, we can say mean is greater than mode. Okay, that your squareness is a positive value, otherwise it is a negative value. Okay, so the relative measures of the squareness, you can say Carl Pearson coefficient of squareness. Okay, it is, so you need to remember this formula: mean minus mode by standard deviation. So if in the exam, if we are given the value of the mean, mode, and the standard deviation, easily you can calculate that what is the Carl Pearson coefficient of squareness. Okay, it is the mean minus mode, okay, divided by the standard deviation. Okay, so that another formula is also squareness is equal to 3 into mean minus median by standard deviation. Okay, so like Calculus Wallace. Okay, so he has also given some other formula how to calculate the squareness. Okay, so it is the median is equal to Q3 plus Q1 by 2, and the Wallace method is Q3 minus median minus Q1 whole divided by Q3 minus median plus median minus Q1. Okay, another method is given by Kelly's. Okay, so he has taken the decile, okay, or the percentile method, P10 plus P90 minus 2 into P50 by P90 minus P1. So this is based on the percentile. This formula is based on the decile, D1 plus D9 minus 2 D5 by D9 minus D5. So D5 is the most middle value, like percentile 50. Okay, movement is again, okay, so movement is what in the general terms that you can say it is the movement of a force. So if we will move from one place to other. That is called the movement. But in statistic, movement means about any arbitrary value. Let's say x is equal to 0. Okay, arithmetic mean. So it is the first movement. Okay, first movement that you can say. Okay, movement about the origin. Okay, so that is m4, m1, m2, m3, m4. Okay, 1 by n summation fx. Fx square is the second movement. Fx cube third movement. Fourth m4. Okay, so if the movement is about arithmetic mean, okay, or the central movement, okay, so this is our general formula. Okay, and mu1 is the first movement, 1 by n, the summation f x minus x bar. Okay, x minus x bar the square, second movement, third movement, x minus x cube. Okay, x4. Okay, so these are all the things that here beta and gamma coefficient. Okay, so here beta 2 that we have seen in the plateautic mesocotic kind of thing. So here beta 1 is equal to mu. Mu means here mu 3 square. Okay, mu 2 cube. Okay, gamma 1 is plus beta 1 root. Okay, beta 2 is mu 4 by mu 2 square. Okay. So according to this beta 2 value, we have that various form of that kurtosis. Okay, so here the measure of kurtosis describes the degree of the concentration of frequency of a distribution. Okay, so now if we have the leptokutic, so here it is the beta 2 is greater than 3 are called leptokutic. Okay, if the value of beta 3 is greater than 3, we can say it is leptokutic. If it is beta 2 is equal to 3, mesokutic, and beta 3 is less than 3, we can say it is leptokutic, what we have shown in this that earlier figure. Okay, so I think so let me show you that one. This one. Okay, so these things we just go through this one. We will if you have any doubt from today's class, you can write in the chat box. Please go through. It is not so difficult. Okay? And you, if you have any reference book also that you can have, practice more and more. Once you practice, then things will be easier. But all this formula, it seems uh, 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 not so confusing. Very very easy. Okay. If you have any query, you can type in the chat box. I'll be waiting 2 minutes. So don't be frightened. Okay. Once you practiced, the formula will be remembered automatically. Okay. But if you don't put any effort on the numbers, then that you may feel it is confusing. Okay. So please find some time and on a regular basis, at least 1 to 3 problems you solve per day. That will give your the confidence that how to solve the problem. Okay. I hope you understood the lessons. Okay. Thank you so much for your patience and hearing. If you have any query, that you can type on the chat box. Otherwise, I'll end the session. Oh, you are writing on the comment. Oh, so sorry. I'm looking the comment right now. Okay, so sorry, sorry. I was looking the chat box. Okay, so sorry. I'm not clearly understood. This is math class. Please show the screen. Screen not show. Okay. Okay, so sorry because I was looking the private chat, but I was not browse the comment. Okay. Okay. Thank you. So from where we get three square. Okay. Screen not visible. So please share the important question. Okay. So we'll uh, try to share the important questions in the next class. Okay. Really, I'm sorry because I have not seen the comment. I just seen the private chat section. That was okay. Okay, we'll try to solve your query. Okay. Okay. Thank you so much. Have a nice day.